This is Jo Karen Hudson speaking. Today I'm going to work with you on section 10.3, adding and subtracting radical expressions. First of all, let's get the definition of like radicals. Like radicals have the same index, they have the same radicand, radicand means what's underneath the radical sign. Only the coefficients differ. Only the coefficients, numbers in the front. Let's look at 4 square root of 2 and 3 square root of 2. Well, first of all, they have the same index. Both of them are a 2. It's not necessary to put the little 2 in a square root. I'm putting it in for emphasis. They have the same index. They have the same radicand, the same number underneath the radical. Only the coefficients differ. One is a 4 and one is a 3. These are like radicals. Negative the square root of 21 and 3 square roots of 21. Again, these have the same index. They're both square roots of 2. They have the same radicand, the same number under the radical, and only the coefficients differ. Now we have 8 cube roots of 11 and the cube root of 11. These have the same index. They have the same radicand. Only the coefficients differ. If there's not a coefficient, it's understood to be a 1. These are like radicals. And so are those. Let's perform the indicated operations. Example 1. The square root of 36 plus the square root of 25 minus the square root of 49. Now, none of these are like radicals at this point, but if I were to simplify these, the square root of 36 would turn into 6, and the square root of 25 would turn into 5, and the square root of 49 would turn into 7. 6 plus 5 is 11, and 11 minus 7 is equal to 4. So we were able to simplify that. Now on example 2, I'm going to actually do this one in 2 ways. Most of you have a calculator that we have programmed or that we can program the complex root program into. I'm going to do it first without the program, and from then on in this module I'm going to use the program to simplify my radicals. So let's do it first without the program. I'm going to need to use my calculator or my list of square roots, perfect squares, to simplify the square root of 8 and the square root of 50 and the square root of 18. If I think of my perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. I think that'll be high enough. So I will start off. 3. Now the square root of 8, let's see what perfect square goes into the square root of 8. 4 will go into that one, so I can change that to the square root of 4 times the square root of 2 minus, now I want to think of the perfect square that will go into 50. Let's see, 25 will go into that one, so I can change the square root of 50 into the square root of 25 times the square root of 2 plus, and I want to think about what perfect square would go into 18, and that would be 9. So I can change the square root of 18 into the square root of 9 times the square root of 2. So now I'm ready to simplify. 3 times the square root of 4 would be 2 square roots of 2, minus the square root of 25 is 5 square roots of 2, plus the square root of 9 is 3 square roots of 2. So now I have 3 times 2, which is 6 square roots of 2, minus 5 square roots of 2, plus 3 square roots of 2. 6 minus 5 is 1, square roots of 2. How do we combine like terms? We combine the coefficients and keep the like part, which is the square root of 2, plus 3 square roots of 2, which would give me a final answer of 4 square roots of 2. Now, I would like to show you how to do this when using the CPLX root program on the calculator. You need to get out your calculator. If you don't have it programmed, you need to get one of us to program it. I'm going to recopy the problem. 3 square roots of 8 minus the square root of 50 plus the square root of 18, and I'm going to use the CPLX root program from now on. So I'm going to start off with 3, and I'm going to use my calculator, my CPLX root program, to break down my radicals. So starting off with the square root of 8. I'll get my calculator, press program in the center, and wherever that program is, you need to come down till you find the one that says CPLX root, right there, and press enter. And press enter again, and then I'm going to say it's a square root, enter, of 8, enter. And I will find out that that will turn into 2 square roots of 2 minus, I'm going to press enter again. It'll keep me in the program. I'm going to take care of the square root of 50. You put the index in for R. Square root of 50 is 5 square roots of 2. So I'm going to change that square root of 50 to 5 square roots of 2 plus the square root of 18 using my CPLX root program, and just pressing enter again keeps you in the program. The square root of 18 will give us 3 square roots of 2. 3 square roots of 2. Now I have 3 times 2 is 6 square roots of 2 minus 5 square roots of 2 plus 3 square roots of 2. How do we combine like terms? We combine the coefficients and keep the like part. The like part is the square root of 2. 6 minus 5 is 1, and 1 plus 3 is 4 square roots of 2. So the program does eliminate one big step. I will be using that program to complete the rest of the problems. If you do not have the program, you will have to do it by the first method that I showed you. I'm going to be using the program to simplify the square root of 75 and the square root of 12 and the square root of 48. So I'll start off 5x, and then I'm going to grab my calculator. I'm still in the program, so I just press enter. It keeps me in it. Square root of 75. And that turns into 5 square roots of 3. So I have 5x times 5 square roots of 3 minus 2x. I'll want to use the program to simplify the square root of 12. Square root of 12, 2 square roots of 3, 2 square roots of 3 plus 3x. I want to simplify the square root of 48. Square root of 48, 4 square roots of 3, 4 square roots of 3. So now I will multiply. 5 times 5 is 25x square roots of 3 minus 2 times 2 is 4x square roots of 3 plus 3 times 4 is 12x square roots of 3. Now I'll go ahead and combine the like terms. 25 minus 4 would be 21x square roots of 3. The x square roots of 3 is the like part. Plus 12x square roots of 3. And when I combine the coefficients, I'll have 33x square roots of 3. And that will be my final answer on that one. Now I can use the CPLX root program to simplify cube roots as well, with a little bit of a variation. So I'm going to start off with 3, and then I'm going to use the program to simplify the cube root of 16. So I'll have 3 times whatever the cube root of 16 gives me, plus 2 times whatever the cube root of 54 gives me. So working on the cube root of 16, I'm going to put in a 3 as the index this time. The cube root of 16 gives me 2 cube roots of 2. You will have to remember to put the little index back in, 2 cube roots of 2. And then I'm going to simplify the cube root of 54, remembering 3 is the index, cube root of 54, and that gives me 3 cube roots of 2, 3 cube roots of 2. Don't forget to put the index back in. Now I have a total here of 6 cube roots of 2 plus another 6 cube roots of 2. 6 plus 6 gives me 12 cube roots of 2. Remember, when I combine the like terms, I combine the coefficients and keep the like part. My last example is a perimeter of a triangle problem, and I remember that when I find the perimeter of a triangle, I just add all 3 sides together. And on this triangle, the 3 sides are, well, the first side is 3 square roots of 5, plus the second side, which is 2 square roots of 5, and the third side is 3 square roots of 7. So I can actually combine these. These are like terms. So I'll have the perimeter is equal to 3 square roots of 5 plus 2 square roots of 5, which is 5 square roots of 5, plus 3 square roots of 7. Now this is my final answer. I cannot add 5 square roots of 5 and 3 square roots of 7 because they are not like terms. This has been section 10.3. I will need you to do the homework on this section as well as the quiz on this section. This is Jo Karen Hudson. Thank you and have a wonderful day.